Have you ever wondered how companies predict trends, or how the weather forecast gets made? Well, the secret lies in the world of data analysis. Data analysis is like the crystal ball of the modern world. It sifts through mountains of information, finding patterns and revealing clues about the future. It's how businesses anticipate customer needs, or how meteorologists predict if it's going to rain next Tuesday. Accurate predictions are the holy grail of many fields, from marketing to meteorology, and they all rely heavily on data analysis. Now you might be thinking, that sounds complicated, I'm not a statistician. But here's the thing, understanding data analysis isn't just for those number-crunching experts. It's a tool that's becoming increasingly important in our data-driven world. From making informed decisions at work to understanding why that online ad seems to know you so well, a basic understanding of data analysis can go a long way. So, understanding data analysis isn't just for statisticians, it's a skill that can benefit us all. But what exactly is data analysis, and how does it work? Well, think of data analysis as a detective story. Like any good sleuth, we begin by gathering clues. In the world of data, these clues come in the form of raw numbers and facts. This is our data collection phase. Next, just as a detective would organize their clues, we tidy up our data. We remove errors, fill in missing pieces, and generally make sure everything is in order. This is the data cleaning phase. Now comes the fun part, piecing together the story. We analyze the data, looking for patterns, relationships, and trends, much like a detective would piece together a sequence of events. This is our data analysis phase. And finally, like a detective predicting the culprit, we use our analysis to make predictions about future data. That's the essence of data analysis, making sense of the numbers to predict and explain trends and patterns. Now, one tool that data analysts often use is called the least squares line. This line is a method used to determine a line of best fit through a scatter plot of data points. But why do we need it? Well, it's all about making predictions. You see, sometimes data can be a bit messy. Points scatter here and there, and it's hard to see a clear pattern. The least squares line, however, helps us draw a line right through the middle of this scatter plot, minimizing the distance of each point from the line. Imagine you're trying to predict the weather for a picnic. You have data on temperature and rainfall for the past few years. The least squares line could help you find a trend in this data and make an informed prediction about whether it's going to rain on your picnic day. The least squares line, then, is a powerful tool in data analysis and prediction. So how do we calculate this least squares line? Let's break it down step by step. First, we need to find the average of our x values and our y values. These are simply the sum of all x values divided by the number of x values, and similarly for the y values. Next, we calculate the difference between each x value and the average x value, and each y value and the average y value. We then multiply these differences together and sum them up. Meanwhile, we also calculate the square of the difference between each x value and the average x value, and sum these up as well. Finally, we divide the sum of our multiplied differences by the sum of our squared differences. This gives us the slope of the least squares line. The y-intercept is then calculated by subtracting the product of the slope and the average x value from the average y value. And that's how we calculate the least squares line. It may seem complex, but it's a systematic process that anyone can learn. Let's summarize what we've learned today. We've delved into the fascinating world of data analysis and how it affects our everyday life. From predicting weather patterns to stock market trends, data analysis is instrumental in making informed decisions. We've also explored the process of data analysis, highlighting the importance of gathering, cleaning, and interpreting data. We then introduced the least squares line, a powerful tool for making predictions based on data. By minimizing the sum of the squares of the differences between actual and predicted values, this line provides us with the best possible prediction. We've also walked through the steps of calculating this line, transforming raw data into a tool for forecasting. So the next time you see a prediction or trend,